Okay. Hello. So in the previous video, we talked about so we said that, well, x1 bar, sorry. So we said that, okay, x1 bar, um, x1 bar minus x2 bar. Well, this difference is again normally distributed with these parameters mu1 minus mu2 and sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. So which means, well, this is approximately standard normal. x1 bar minus x2 bar minus mu1 minus mu2. Okay. So divided by this whole mass, sigma 1 squared divided by n1, sigma 2 squared divided by n2, this is in this square. Okay? So that's great. Now we will see how to use this test statistic, okay, how to use this one as a test statistic to make our hypothesis test, okay? So now let's remember we have the 5-step procedure. So step one is just write your hypothesis. So in this case, when comparing two means, our hypothesis is of the form uh, like this. Mu1 minus mu2 is equal to some number, okay? It can be 1, minus 3, 10. In most cases, we just deal with uh, two means, whether they are equal to each other or not, okay? So most of the time, we just take this d0 as 0. But as I said, it can be any number. Versus h1, so this is mu1 minus mu2 is in fact not equal to d0, right? So step two, just pick your test statistic. Well, I know that this z is related with x1 bar minus x2 bar, which is also related with this one. So in fact, I can just use the z, right? This is my test statistic. So step three, um, just find your critical region. Remember the critical region. Well, since I'm just using z, I have just standardized this. It's very easy to find the critical region, r minus z alpha over 2, z alpha over 2. So this is my critical region. And step four, calculate your observed test statistic, which is z observed in our example. This is equal to x1 bar, right, observed. So this is the value that you observe. For example, if you're just testing, whether the GPA of female students is equal to GPA of male students plus some, let's say 0.5. Okay, let's say this is mu1 minus mu2 is equal to 0. Let's say 5. Mu1 is female student GPA, and this is the male student GPA. Okay? Then what you do is you just go to the class, ask the GPA of female students and take their average. This is your x1 bar observed, minus you just ask the male students, that's your x2 bar observed, minus this is mu1 minus mu2. But what is mu1 minus mu2? Well, it just comes from the null hypothesis. Remember, we said that, okay, this one, so we assume that null hypothesis is true. This is the basic thing when you're just making a hypothesis test. So mu1 minus mu2, sorry. So mu1 minus mu2 is in fact d0. Okay? That's equal to d0. Um, that's equal to d0 divided by sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Okay, this is in the square root. This is given in the question. This is given because we said that, well, this is the case where you know sigma 1 and sigma 2. Okay, and this is my z observed, right? And step 5, so step 5 is conclude. How to conclude? If z observed is in this critical region, okay, then you reject the hypothesis and say that, well, mu1 minus mu2 is not equal to d0, okay? You cannot say that, well, the difference between the male and female students, difference between the GPA is not equal to 0.5, okay? So you just reject the hypothesis. So if it's not in the critical region, you can say that, well, the difference can be said to be equal to 0.5. I cannot reject this hypothesis. We will see some questions and that will be crystal clear, okay, when we just solve the questions. So in fact, this is what we did in the previous slide. So, okay, so this is the observed equal to x1 bar. So this is observed and this is observed. V0, this one just comes from the null hypothesis divided by this, okay? And this is my critical region, okay? What is the critical region again? Minus z alpha over 2, z alpha over 2, okay? So if the observed is in the critical region, which means if it satisfies this, then you just reject the hypothesis. So this slide is just in fact a recover of the previous slide, okay? So what is the confidence interval for the difference of two means when sigma is known again? So we are just continuing the same case for sigma known case, and we are talking about the confidence interval now. Now remember how we find the confidence interval? We just write the probability expression for the standard normal, and we say that, well, that's equal to 1 minus alpha. So remember, I don't know whether I have it or not. Okay, just go back. So here, remember, this is the standard normal. Okay, oh, that's great. And I just set alpha over 2 here and alpha over 2 here. This is minus the alpha over 2, so the alpha over 2. Okay. And this is z alpha over 2. Okay. And this probability here, this area here is equal to 1 minus alpha, right? Now how can I write this? This is equal to, in fact, this one, right? This one. Probability that z is between minus z alpha over 2 and z alpha over 2, that's equal to 1 minus alpha. What's next? I know that, remember, x1 bar, sorry, x1 bar, sorry for this, minus x2 bar minus mu1 minus mu2, which comes from the hypothesis as d0 divided by sigma 1 squared divided by n1, sigma 2 squared divided by n2, okay? I know that what this is approximately standard normal, so I just plug it there, remember? So let me just erase this, and instead of, let me just write the original one, which is mu1 minus mu2, okay? Because now we are not doing the hypothesis test, but we are just dealing with the confidence interval. And after plugging this value, plugging this whole fraction into z, into here, then after making some algebra, it turns out that, well, the difference between the unknown parameters, mu1 and mu2, is given by this interval, okay? x1 bar minus x2 bar, so let me just, so this is x1 bar minus x2 bar minus z alpha over 2 times sigma 1 squared and 1, sigma 2 squared and 2, okay? And here I have a plus here, right? Okay, so just please notice the similarity between this one and the previous confidence interval. So previously we said, well, this is mu, okay? Mu is between x bar minus z alpha over 2 times sigma over n. So instead of x bar, I have now x1 bar minus x2 bar, z alpha over 2, z alpha over 2, that's the same. So instead of sigma over root n, I have this variance, which is sigma 1 squared divided by n1, sigma 2 squared divided by n2. So in fact, you can just write this as sigma squared divided by n, and just take the square root of this, okay? So when you just make this one, you will see that this is much more similar to this one, okay?